Okay, hi. So this is week 4, and today we'll start new topic, term frequency weighting. It is about so as before we continue with Stanford lectures. Uh, some point. So it is this one, part 2. I will go back to part 1 later on, but now we will start with this part. Sorry. So and also will not start from the it is information retrieval second slide, and also it is not from the beginning, it's from the middle. So we will go through the term frequency weighting. So let me explain. So this is the classic document. So these things are documents. Sorry. So these are documents. These are documents, and so these are some Shakespeare's writings, and these are people's or terms that are used in these things. So this is a binary term document. This means that Antony was mentioned in this document, Antony and Cleopatra, and for example Caesar was not mentioned in the Tempest document. So we have this method. This is also called bag of words. So it means that you only consider each of them as does it consist or not. Term document count matrices. So for example, this one is different somehow. This you say that Antony was mentioned in Antony and Cleopatra 157 times, and 73 times in Julius and Caesar, 0 times in Tempest, 0 times in Hamlet, 0 times in Othello, and 0 times at Macbeth. So this is again explanation. So how many different documents are used? Bag of words model. Vector representation doesn't consider the ordering of the words in documents. So it means that, like in previous example, you do not consider how they are ordered. So for example, in these two texts, John is quicker than Mary, Mary is quicker than John. It is like they are not same, but these models, bag of words models, they do not consider these things. They consider them as same vectors. But they don't consider, but in many cases we do not need to consider these things. So because of this, it is used as bag of words model. Term frequency. Let's go further. Of term T in document D is defined as number of times that T occurs in D. If you want to use TF when computing query document by scores, but how? So, for example, means that term frequency is term T in document D is defined as number of times that T occurs in D. So, for example, in your document you have thousands of words. Let me write here. Say 1,000 words in document. 1,000 words in document, and you have 50 hello in this document. So TF will be equal to 50 divided by 1,000. So this is called term frequency. I can draw it like this. And log frequency. The log frequency. So we can also do this one. So this is the sum formula. Instead of this, you can use log frequency, weight of term T in D. So you calculate how many times this is in document, and use it as a log. So why do we do this one? Because, for example, 0 will go. Okay, so in this case, it is not only term frequency, but for example, you can do it as this one. Term frequency, that means that how many words are there in this document. So for example, in this case, it will be 50. Term frequency 50. So to calculate this one, you will have to do something like this: 1 plus logarithm of 50. If it is more than 0, if it is 0, it will be 0. So why we need this logarithm? Maybe consider it as counterintuitive, but it means that, for example, if you have 1, it will be 1, but if you have 1000, so it will be 4. So sometimes, for example, in some document you will have thousands of some word, but in other 100. But they are actually, like, you have a document which has 100. So like in this case, for example, 1 1 and 2 1 3. But if you do not use logarithm, it will be 1 will be 1 and 2 2. So if you do not use logarithm, what does it mean? It means that or maybe 3. Oh, this will be 2 3, something like this. So if you have, for example, one apple, word apple in document, and in other document you have 2 apple. What does it mean actually? It means that so if you will assume them as numbers, so it means that this document is 2 times much about apple than this one. But in real life you will see that. So for example, if in some document there are two mentions about apple, it's not 2 times important for apples than this one. So to make it like less depend on numbers, we use this logarithm. Document frequency. So this is called term frequency. It is only how much terms we use in this one. Later we'll see the exact formulas. Now document frequency. So in previous example we had how many times word apple is met in this document. So for example, if you have in document 10, for example, you have hundreds thousand word, and you have 10 apple, or for example politics, and 1 word sports, 100 politics. So actually it is like it's some document in which it is most likely to be about politics, and sports maybe about, there is something about sports, but it's not like comparable with this one. So the term frequency was to understand, for example, so the term frequency means that this document is more about politics than sports. You divide how many times this amount to this amount of all words. Whilst document frequency means that we have 10 documents, 10 documents, okay, 10 documents, and word, for example, politics, let's say thousands of documents, and word politics is met in 10 documents, and for example vice versa, for example, and word is in 999 documents, and 1, for example, and word arachnocentric is in is in 2 documents. So what we see from this case, so for example, you have 10,000 documents, you do not know, you know nothing about this one, but you want to gain some insights. So for example, the word politics in 10 documents and word is in 999 documents. What does it mean? That is, it actually means that is very common word, so it doesn't give us anything about document it has. So for example, if you know that word politics is in document, it means that it has something specific about it. So it is about politics. Or for example, if you have word arachnocentric in 2 documents, that this means that this somehow specifies, this word somehow specifies the document. So for example, you understand by seeing that this word is present in this document, you will understand that this means something to this word. So what does it mean? Rare terms are more informative than frequent terms. So in this case, arachnocentric is very rare term, and is very frequent word. So is doesn't give us any understanding about document, but arachnocentric gives us. So we can clusterize them. So we can recall stop words. Stop words are these is words, like the common is, are. So in Kazakh, in Russian, they may be like болды, kabuldadı, etc. But actually maybe like men, shlau, which are functional words, they are also like used that. A document containing this term is likely to be relevant to the query arachnocentric. So for example, if you are searching arachnocentric, it will show you. We want a high weight for rare terms. So in this case, we want to make measurement for this word with higher weight. Frequent terms are less informative than rare terms. So like in example, is versus arachnocentric. Okay, this is about this one. Consider a current that is frequent in the collection, high increase line, so this is these words. A document containing such term is more likely to be relevant than a document that doesn't. So if it is arachnocentric, you'll search it. But it's not sure. For frequent words, we want positive weights for words like high. Yeah, okay, so these words are also frequent, but we want to give more weights also, but lower weights than for rare terms. So rare terms must be better, but may have high weights. These terms also should be positive weights, but there should be less than. So we need to create new second thing is IDF weight. Document inverse document frequency, the number of documents that contain T. So for example, this can be considered as something like this. So for example, you have 10 documents containing arachnocentric. Well, 10 documents out of 1000 contains word arachnocentric. So to calculate this one from this one, we can do it like this. So we say that n will be 1000 with the f is document frequency. So this is how many documents are like 10, and we use logarithm, so this means that it will be 1 over 100. 1 over 100. So to find out TF-IDF, you will delete this 1000 by 10, so it will be 100 actually, and you will take logarithm of this one. So for example, Calpurnia is met is only once the document frequency. So you divide this number of documents, 1 million divided by 1, so it will be 1 million, and you take logarithm of this one, and you will get logarithm of million. It is 6. Yes, 6. This will be 4, 3, 2, 1 and 0. So why this is 0? It is the word is in all documents, so it will be 0. You can neglect this word. It is not like this word should not be considered. But for example, these words Calpurnia, animal, Sunday, fly, and they should be considered in some way. Effect of IDF on ranking. Does IDF have an effect on ranking for one-term queries like? IDF has no effect on ranking one-term queries. IDF affects the ranking of documents for queries with at least 2 terms. For the query Calpurnia spelling, IDF. Okay, so if you have one-term query, you will not. So for collection versus document frequency, the collection frequency of T is number of occurrences of T in collection counting multiple occurrences. So for example, there are two things like insurance and try. Insurance is met in collection, in our collection, 10,440 times. Whilst it is met in documents 3,997 times. So like rare, it is used many times in all documents, but it is used mainly in some documents, in only this part of documents. But word is used, word try is used also same amount of times, but it is used in many documents. So the word is which word is better search term and should get a higher weight, and the word insurance is better search term because it is met in less documents than this try. If so, how many times word try is used in these documents? Then in many documents, this in same amount it should not be considered as a search term. So we got to the next topic is TF-IDF. We combine these weights. So first of all is TF weight, term frequency, and this one is the formula. Term frequency, as we said, that how many times the word is met in this document, whilst this DF is how many times this word occurred in all documents, how many documents contain this word. So we can state this one. TF is how many times term occurred in this document. The maybe important word is here this. And this one, document frequency, how many documents have this word. So this is very important part. TF-IDF is hyphen, not inside. Alternative names TF-IDF, TF-XIDF. So sometimes they use it. So maybe some of people may understand that this is some formula like term frequency minus IDF increases with number of occurrences. So it means that it increases if number of occurrences within document. If you have many words insurance, then this document's insurance weight it increases. It also increases with the rarity. So if you have rare elements, it will also increase. So this is the formula. Binary count. So this is the example. Okay, this is TF-IDF weights. So they are multiplied. Sorry. So we can apply these formulas like this one. 1 plus log TF, and then you will get something like this. So now let's see. This is words Anthony. For example, it is more important here because it occurs many times. It's less occur here 318 because it occurs this amount of times, Macbeth, etc. Now we have V-dimensional vector space, theorem axle space. Documents are points of vectors in this space, very high dimensional, tens of millions. These are so actually this thing we converted the documents like text into these vectors. So for example, this one is some vector. By looking at this vector, we can work with other machine learning methods. So all machine learning methods actually they based on these kind of vectors. You give the vector and it makes something. You give, for example, all vectors and try to classify something, and then you give new vector and it will be classified with this new vector. Do the same for queries, represent them. Okay, and then we can do some small explanation. So for example, you want to understand if the two vectors are same or not same. So what you will do, you will compare two vectors. And we have here some, for example, vectors gossip jealous. If two documents are same or not same. So for example, Euclidean distance, and this is document 1, document 2, document 3. And if you use Euclidean distance, you'll measure, so this is new document and you want to measure which of them is near. So for example, if you use Euclidean distance is the distance between these points. You will see that D1 is actually nearer to Q than D2. So to solve this problem, we use cosine distance. Cosine distance takes this dot product and then divides it by multiplication of this. So actually this is the formula. You have two documents. Cosine distance is something like this: 3, 2, for example, and 1, 1. This is vector 1, this is vector 2. And to take cosine distance, you do something like this: 3 plus 3 times 1, 3 times 1 plus 2 times 1, and divide it to 3 times 9 plus, so it will be 3 times 3 plus 2 times 2 under the square root plus, and we cannot read right here, plus it will be 1 times 1 under the square root plus 1 times 1. So this is actually cosine distance, and this cosine distance helps us to measure the similarity between these documents.